lastly, I'm going to talk about a technique called chromatography. So in chromatography, the principle is that a known solvent is going to move over an absorbent material, which can be a paper or a gel, okay? And this is geared towards separating solutes of a mixture. So a known solvent is moving over an absorbent material, which can be a paper or a gel, and once the solvent is moving over this material, it's going to separate a known amount of solute of a mixture. So we have types of chromatography, which includes the gas chromatography and also the ascending column chromatography. But the most popular one is ascending column chromatography, which I'm going to discuss briefly. So in ascending column chromatography, you're supposed to have an absorbent material, which I said earlier can be a gel or a paper strip. So this material is put in an airtight chamber that must have some lids. So this lid is just to make it airtight. So a particular spot is now made on the material. So this spot contains a mixture of solutes to be separated. So once the spot is now made on the paper, on the material, a known amount of solvent is now introduced into the chamber. So this solvent is chiefly put into the chamber. Also, when putting the solvent into the chamber, care must be taken to not allow the solvent to touch the spot, okay? But the solvent has to meet with the paper, the absorbent material, paper or the gel. So this chromatography, it has two major phases. It has the moving phase and you have the stationary phase. In stationary phase, okay, this solvent here is going to dissolve this particular this mixture here. Okay, that's the stationary phase. Why the moving phase is that once this particular mixture is dissolved in this material, this mixture will be carried along as this solvent is moving along this paper. Like I told you, I'm explaining the ascending column chromatography because this solvent is going to ascend this particular material, be it paper or gel. So in this phase, stationary phase, first of all, the solvent is going to come here to dissolve this particular mixture in the stationary phase. While in the moving phase, the dissolved mixture is going to ascend this particular material. So this separation, depending on the duration, this particular mixture is going to be singled out. It's going to be separated in this particular material. By the end of this technique, they're going to bring out this material, the paper or the gel. So once we bring out this paper out, this was our spot, initial spot. So by the end of this separation, this solvent is going to separate the mixtures into various spots. But these are our original spots. But before you bring out this paper, you must first of all wait for this solvent to reach about 3/4 of this column. So if this is our first quarter, second quarter, third quarter, and last quarter. So this is our first quarter, second quarter, third quarter, and what, fourth quarter. So they're going to allow the solvent to at least reach 3/4. So that's here, 3/4 of this whole column. So once you have reached this 3/4, now you can now break out this particular strip of material, be it paper or gel, to now see how this mixture is being separated by these different dots. So this chromatography, you employ it basically in some scientific analysis. So maybe when you want to study, for example, mixtures like dyes and also like some amino acids. So it's basically used in some scientific analysis in some laboratories to see the nature of these dyes and amino acids. So that's for chromatography. So once you are done with these separating techniques, you tend to get a pure mixture. So once you are done separating these mixtures, you tend to get a pure mixture. So that's what we call a test for purity. So this test for purity tends to ascertain how pure a mixture is. Test for purity entails two major parameters. You have the melting and boiling point, and you have the plots on chromatogram. You want to test for how pure a mixture is. So those particular mixtures, they have a specific standard melting and boiling point. So these points, they are standard. So once you melt or you boil a particular mixture and the value you get from the boiling and from the melting does not tally with the standard boiling point or the standard melting point for that particular mixture, that mixture is now impure. Impurities, they tend to elevate. Impurities, they elevate boiling point, while they decrease the melting point. For example, if you have a mixture A that have impurities, So these impurities make this mixture A to be impure. So once you want to melt this particular mixture, let's say the standard melting point of this impurity of this mixture is 35 degrees Celsius. This is the standard melting point of this particular mixture. But because this mixture have impurities, if you then want to melt this particular mixture, it's going to melt at a temperature below the standard melting point. It's going to melt below 35 degrees Celsius. Does it make sense? Nice. So for instance, if this is the standard boiling point of this particular mixture, if you now want to boil this particular mixture, it's going to elevate. So it's going to boil at a temperature above 35 degrees Celsius. The impurities, they tend to elevate or tend to decrease the melting and the boiling point of a particular mixture. So if you want to test how pure that the mixture is, you have to check for the melting and for the boiling point. Okay, so the second factor is the spot on the chromatogram. So a pure mixture will give one particular spot in the chromatogram. But if that particular mixture is impure, it's going to give various and multiple spots on the chromatogram. That's in chromatography. So that's a wrap, guys. I believe you have understood what separation technique entails. But if you have any question of any type, let me know in the comment section and I'll get back to you as soon as possible. Please make sure you like this video, subscribe to this channel, and also share this video with your friends. For now, bye bye.